Objective 1.5, completing the square. In this lesson, we want to be able to complete the square to make an expression a perfect square trinomial. And then we want to use this process of completing the square as yet another method for solving quadratic equations. So, we're going to start out with a video that should correlate to what you saw in the little introductory activity. Hopefully you see the connection, and then we'll talk a little bit about some vocabulary that goes with that. But let's watch the video first.
Use completing the square to find the value of c that makes x squared minus 44x plus c, so we need to figure out a c, that makes it a perfect square trinomial. Trinomial is just a polynomial with three terms here. Then write the expression as the square of a binomial. So we have x squared minus 44x plus c. So how do we make this into a perfect square? Well, if you just look at the traditional pattern for a perfect square, let's just think of it in terms of x plus a squared. That's the same thing as x plus a times x plus a, and we've seen this before. And if you were to multiply this out, that's x times x, which is x squared, plus x times a, which is ax, plus a times x, which is ax, plus a times a, which is a squared. So it's x squared plus 2ax, these two, you have an ax plus an ax, gives you 2ax, plus a squared. So if we can get this into this pattern, where I have whatever value is here, if I take half of it, right, this is going to be 2a here, if I take half of it and square it over here, then this will be a perfect square. So if we look over here, this thing right here is 2a. If we want a pattern match, if we want to make this look like a perfect square, that has to be 2a. So negative 44 is equal to 2a. And this right here, this c, if we pattern match, that has to be equal to, c has to be equal to a squared. So what's a? Well, if we know negative 44 is 2a, we can divide both sides of that by 2. Divide both sides by 2, and we know that a, or we know that negative 22 has got to be equal to a. A has got to be equal to negative 22. A is half of the coefficient right here. It's half of negative 44. And whenever you complete the square, it's always going to be half of the coefficient right here. Now, if that's a, what does c need to be? Well, c needs to be a squared in order for this to be a perfect square. So c needs to equal negative 22 squared, and we can figure that what that is. 22 times 22, we could put the negative later, actually it's going to be the same thing because the negative times the negative is a positive. 2 times 22 is 44, put a 0, 2 times 22 is 44, get a 4, get an 8, get a 4. So it's 484. So if we were to rewrite this as, x squared minus 44x plus 484, then this is a perfect square trinomial. Or we could write it like this. This is x squared minus 2 times, or maybe I should write it this way, plus 2 times negative 22x plus negative 22 squared. And when you view it that way, it's pretty clear that this is a perfect square, and then if you were to factor it, it's the same thing as x minus 22 times x minus 22, or x minus 22 squared. These are all equivalent statements.
All right, so hopefully you see the connection here between what Salman Khan is showing you in the video and what you were seeing in the activity. The idea that if you take half of the coefficient on x and then square that, you'll get that missing piece that will give you the perfect square trinomial. And that's really what our vocabulary is trying to show us today. It says completing the square is the process of rewriting an expression that starts out as the form x squared plus bx as the square of the binomial. So to complete the square for x squared plus bx, you need to add the b over 2 squared. Okay, so this is their way of saying take the coefficient on x, which was b, divide that by 2, take half of it, and then square that. And if you do that, then you get x squared plus bx plus whatever that number was, your half of b squared. That can then be rewritten as the square of a binomial, which is going to be x plus that b over 2. Just like his a that he was talking about in the video. Okay, that a comes from taking half of b. Okay, this is what we need to use for completing the square. So just to make sure that you're comfortable with this, let's try a couple of quick examples where you need to first find c to make it a perfect square trinomial, and then write the expression as the square of a binomial. Pause the video for a moment while you try that. Come back when you're ready to check your answer. All right. So in the first case, if we take half of the 6, we get 3, and then 3 squared will give us 9. So the perfect square trinomial is x squared plus 6x plus 9. And then when we rewrite that as the square of a binomial, we take the x plus the 3, which was the half of b that we got in the first place, x plus 3 quantity squared. Similarly in part B, if we take the half of negative 12, we get negative 6. When we square that, it's still a positive 36. So x squared minus 12x plus 36 is our perfect square trinomial. But when we write that as the square of a binomial, we need to make sure that we're saying it's x minus 6 quantity squared, because the half of b was a negative 6. All right, so let's actually use this process now as a way to help us solve an equation. So we're starting out with the equation x squared minus 2x minus 2 equals 0. Okay? Now, if you look at what's in this constant spot right here, you can pretty quickly see that that is not the number we need in order to have a perfect square trinomial. So we're going to make it work. And we're going to make it work by making room for a proper c. In other words, we're going to move that minus 2 out of there so that we have room to put in whatever the number should be. So that means adding the 2 to both sides and then leaving a space there for whatever c should be. Okay, now we're going to go through the process of actually figuring out the c, just like we were doing in our previous examples. So if we take the half of negative 1 and we square it, we end up with a 1. But notice here that if I'm going to add 1 on this side in order to complete the square, because this is an equation, I also have to remember to add the 1 on the other side to keep things balanced. So I add 1 to both sides, and now I'm going to rewrite the left side, my perfect square trinomial, as a binomial squared, and I'm going to simplify the right side. So x squared minus 2x plus 1 is going to become x minus 1 quantity squared, and then on the right side the 2 plus 1 is going to become 3. Now that I have my equation in this form, now I can take square roots as a way to finish out the solving. So what we were doing last lesson with taking square roots comes into play now at this point as a way of coming to our final answer of what x should be equal to. So we take the square root of both sides, and again, don't forget that it's plus or minus the square root of 3. And then we finally get x by itself by adding the 1 to both sides. So we end up with a solution of x equals 1 plus or minus the square root of 3. And that is using the process called completing the square. All right, why don't you give it a shot? See if you can go through that same process using this particular equation of x squared plus 6x plus 5 equals 0. If you're not sure, go back and rewatch that last example and then give this a shot. Pause your video for a moment while you work. Come back when you're ready to see if you got the answer right. All right, so here's what it should look like. First, we need to get this 5 out of the way. So we've subtracted it over to the other side. Then we take half of this 6, which is 3, square it, and we add that 9 to both sides. That puts us with a perfect square trinomial on the left, which we can rewrite as x plus 3 quantity squared. And we can simplify the negative 5 plus 9, which gives us the 4. Now we take the square root of both sides, so that leaves us with x plus 3 on the left and a positive or negative 2 on the right. Then we can subtract the 3 from both sides to get x equals negative 3 plus or minus 2. Now because this was not a radical, because our 4 is actually a perfect square and I can actually get an answer from taking the square root of it, I need to take this one more step and actually work out the answers. So what is negative 3 plus 2? That's going to be negative 1. And then what is negative 3 minus 2? That's the negative 5. So we don't want to stop at this step in this case because there are no radicals involved. We can actually simplify one step further to get actual answers of x equals negative 1 and x equals negative 5. No radicals, nice simple answers, and we need to have that simplified as much as possible. All right, let's take a look at another example. What happens when a is not equal to 1? So in our previous example, we did not have a coefficient out in front of x squared. Here we do. We can see a 4 as our coefficient. Well, when we're using an equation like this, we need to realize that the completing the square process only works when a equals 1. So we need to make that happen in this equation, and we're going to do that by dividing everything by 4. So that changes our equation to x squared plus 6x minus 2 equals 0. Once we've changed the form so that a is equal to 1, now we're right back to doing a problem just like the previous example. Excuse me. So we'll add the 2 over to make room. Then we'll take half of 6 to get 3 and square that. So we add 9 to both sides. We change our perfect square trinomial into a binomial squared, which will be x plus 3 squared. We simplify the 2 plus 9 to get 11. Then we can take the square root of both sides and subtract the 3 from both sides. Now in this case, because we did get an actual radical when we took the square root, this is as far as we can go. A negative 3 plus or minus a square root of 11 is as simplified as our answer can get. All right, why don't you give this one a try? We're trying to solve 3x squared plus 12x minus 9 equals 0. Get it into a form that allows you to use completing the square to solve it, and then work through the rest of the steps to get your solutions. When you think you've got them, come back to check. All right, so the first thing we would need to do is divide everything by that 3, which is the coefficient on x squared, so that we change that into a coefficient of 1. So that makes our equation x squared plus 4x minus 3. Then we add the 3 over to the other side, take half of b and square it, so that's going to give us a 4 that we need to add to both sides. Then we rewrite the perfect square trinomial into a binomial squared, so x plus 2 quantity squared is going to equal to the 3 plus 4, which is 7. Take the square root of both sides, so x plus 2 is going to equal plus or minus square root of 7. And then finally subtract the 2 to get x completely isolated and to get a solution of negative 2 plus or minus the square root of 7. Alright, so that gives us another method for solving quadratic equations. This is the method you'll be using in your practice problems for Objective 1.5 in your booklet. Even if you can use another method for solving, in this particular practice, only use completing the square so that you get good at that particular method. If you have any questions, find the resources you need to answer those questions as you go. Don't forget to check your completed practice with the answers posted on Canvas. And that'll do it for this lesson. We'll see you next time.